Hi everyone, welcome to today's learning. Today we are going to discuss about gradient descent algorithm. This is a widely used optimization algorithm in machine learning and deep learning for finding the optimal parameters of a model. To begin with, let's understand the concept of optimization. In machine learning, optimization is the process of finding the optimal set of parameters for a model that minimizes the error or loss function. The gradient descent algorithm is one such optimization algorithm that finds the optimal parameters of a model by minimizing the cost or loss function. The gradient descent algorithm is based on the idea of taking small steps in the direction of the steepest descent of the cost or loss function. In other words, it tries to find the direction in which the cost or loss function decreases the most and takes a small step in that direction. Before going in detail of gradient descent, we need to understand what is local minimum and local maximum. A local minimum is a point in the function where the function is lower than all nearby points. In other words, it's a point where the function reaches a minimum value in a small neighborhood of the point. Similarly, a local maximum is a point where the function is higher than all the nearby points. It is important to note that local minimum and local maxima are different from global minima and global maxima. A global minimum or maximum is the absolute minimum or the maximum value of the function over its entire domain. A local minima or maxima is only the minima or maxima value in a small neighborhood of the point. Now let's define about learning rate and the cost function. The learning rate is a hyperparameter that determines the step size at which the model's parameters are updated during training. If the learning rate is too low, the model's parameters will be updated too slowly and it may take a long time for the model to converge. If the learning rate is too high, the model's parameters will be updated too quickly and the model may not converge at all. Therefore, choosing an appropriate learning rate is crucial for efficient and effective training of ML models. Then comes the cost function. The cost function measures the error between the predicted and the actual values of the output. In other words, it measures how well the model is performing. The goal of training a machine learning model is to minimize the cost function, which means reducing the difference between the predicted and actual values. There are various types of cost functions such as mean squared error, cross entropy, and hinge loss are there. The choice of cost function depends on the type of problem and the nature of the data. The learning rate and cost function are closely related because the learning rate determines the speed and efficiency of the optimization process, which is aimed at minimizing the cost function. If the learning rate is too high, the optimization process may overshoot the minimum and diverge, resulting in a higher cost. On the other hand, if the learning rate is too slow or too low, the optimization process may get stuck in a local minimum and fail to converge to the global minimum, resulting in a higher cost as well. Therefore, finding the optimal learning rate and cost function is a balancing act. Now we'll see what are the steps we need to take for calculating the gradient descent. First, we need to initialize the parameters, then we need to compute the loss, and we need to compute the gradient and update the parameters, and then we need to repeat the process and we need to evaluate the model. To understand this concept, let's take an example of a simple linear regression model. In a linear regression model, the goal is to find the optimal values of the slope and intercept that minimize the mean squared error between the predicted values and the actual values. The cost function for a linear regression model is the mean squared error. Now let's see how the gradient descent algorithm works in finding the optimal values of slope and intercept. The first step is to initialize the slope and intercept to some random values. Then we calculate the loss function. Next, we calculate the gradient descent of the cost with respect to the slope and intercept. The gradient is nothing but the slope of the cost function at a particular point. Once we have the gradient, we can update the values of the slope and intercept using the Formula: new slope equal to old slope minus learning rate into gradient slope. We repeat this process of calculating the cost function, calculating the gradient, and updating the values of the slope and intercept until we reach a point where the cost function is minimized. The gradient descent algorithm can be implemented in multiple ways. We have batch gradient descent, stochastic gradient descent, and mini batch gradient descent. In batch gradient descent, we calculate the gradient for the entire training set and update the parameters once for the entire dataset. In stochastic gradient descent, we calculate the gradient for each training example and update the parameters for after each example. Stochastic gradient descent is faster and more efficient than batch gradient descent. Mini batch gradient descent is a combination of both batch gradient descent and stochastic gradient descent. That's all for today, guys. Thank you for watching the video.